everybody. In this video, I'm going to be going over Unit 1, Lesson 1 practice. This is your assignment that you should be working on during your second block period. So if for some reason you were stuck on this, you can use this video to help you, but I'm hoping that you attempted some of these on your own and you don't want to just look at these for the answers. So question number 1 says, here's a figure that looks like the letter A, along with several other figures. Which figures are scaled copies, and explain how you know? So we have two parts to the question. I need to figure out which are scaled copies of the original letter A, and then I want to explain how you know. So this is kind of like the letter F task that we did in class. I need to analyze the original letter and see if any of those other copies are the same exact shape, just different sizes. So no parts of them are stretched in any weird type places. Okay, so if I'm just glancing at my work here, so I can see my original figure, it looks pretty square. I want to notice, is there anything here I can take off the list right away? We talked about scaled copies not being stretched in any weird type way. I can look at figure 3 and notice that it looks a little wonky, right? I have a straight line here and then a diagonal. That is nowhere near the same shape as my original figure. So right off the bat, I really don't have to calculate anything. I can take this out of the running. I know that's not going to be a scaled figure. My original letter A looks like whatever the height of it is pretty much exactly the same as the width. Okay, it looks pretty consistent. However many blocks stand up in the letter is the same amount of blocks that go across. So I'm going to look more at these figures. Is there anything else I notice that I can take out? If I look at figure 1, my number of blocks that count up, I have 1, 2, 3. So in order for it to match this, right, I have 2 blocks going up and then I have 2 blocks going across. So I would want to make sure that if I have 3 blocks going up here, I have 3 blocks going across. But if I count them, I only have 1, 2. So that doesn't match, right? I have 2 blocks here, 3 blocks here, where in my original, they're exactly the same. I have 2 and 2. So that's not the same shape, right? Part of it got stretched in a different way than another part of it did, so I can eliminate that one. So again, whenever we're looking for scaled figures, we're always looking for some kind of pattern. My pattern here that I'm noticing in my original figure is that however many blocks I count at this distance is exactly the same as the number of blocks that I count in that distance. So I'm looking for that pattern in my other figures. So let's move on to figure 2. Count across, I have 1, 2, 3, 4 blocks connecting those bottom pieces. So I'm going to do the same thing. I want to make sure that when I count this top piece here, that vertical piece going right through the center, I need it to be equal. So I have 1, 2, 3, 4. So that fits my pattern. I have 4 blocks going up, 4 blocks going across. So that's the same pattern, that's the same shape. So that's one of my scaled copies. Now let's take a look at figure 4. I have 1 block going across, and then if I count, I have 1 block going this way too. Those are also the same, so I can click a check mark. Those are my scaled figures. So let's go back to the question. Which figures are scaled copies of the original? We want to make sure that we're answering this in full sentences. If you don't like your handwriting, you can always use this type tool. Whatever you're working in, you can always type. So which are scaled copies? So I'm going to go ahead and write figure 2 and figure 4 are scaled copies. And then I want to make sure I'm going in and explaining why. So figure 2 and figure 4 are scaled copies because they follow the same pattern in the original. Again, we talked about that pattern being that whatever my length is here going across is the same length going up. So I noticed that in figure 2, those distances were equal, and in figure 4, those distances were equal, whereas in figure 3, that was completely stretched. It didn't even match. And then here, I was a little bit taller than I was wider, so those aren't my scaled copies. Moving on to question number 2. It says, Tyler says that figure B is a scaled copy of figure A because all of the peaks are half as tall. Do you agree with Tyler, and explain your reasoning? So before we start actually formulating our complete answer, we're going to take a minute just to analyze the shapes. So if I look at shape A, I notice that this is 4. And then I'm also noticing that my distance here, so that width, looks like it's the same in all of these spaces that I'm highlighting. So that length through the whole letter looks like it's the same distance. So now let's read the question again. It says, Tyler says that figure B is a scaled copy because all of the peaks are half as tall. Okay, so I agree with that statement. I agree that this is 4, so then this is 2 centimeters. So that's my same pattern. He's saying that all of these peaks, this length is half. This is half. And I have half and half. Okay, so that is a pattern. However, I'm noticing a part of this figure that doesn't look like it's exactly the same shape. The other thing I noticed, remember, is that I said all of these widths were exactly the same. So that means if it's a scaled copy, then all of these widths have to be exactly the same, which those ones are. But then if we come down here and look at these vertical ones, those are a little bit different. So do I agree with the statement that says it's a scaled copy? I'm going to go ahead and say I do not agree because the base, and we're going to make a note to show what the base is. So the base is too skinny. Right? It's not the same shape. Moving on to question number 3, it says, here's a picture of the Rose Bowl Stadium in Pasadena, California. So unfortunately, the way these worksheets are set up, it's kind of difficult to see, but I have a picture of Rose Bowl Stadium, Pasadena, California. When we move to the next page, now we can see it. So here's my picture of the Rose Bowl. Question 3 says, here are some copies of the picture. Select all of the pictures that are scaled copies of the original. So main idea here that we should be taking away from lesson 1 is that scaled copies are exactly the same shape. So they're not wider, they're not taller. Both of those dimensions get moved by the same amount. So if I'm stretching it wide, I need to be stretching it the same amount tall. So I don't want it to look like it's stretched in any new direction. So if I'm looking at these pictures, does A look like it's the same shape? I would say yes. Whenever I'm looking at scaled copies, I want to make sure that I'm kind of picturing it as if I took this picture and I pulled it from the corner, right? I didn't pull it from this vertical side to make it wider. I didn't pull it from this horizontal side to make it longer. I took it from this corner piece and I stretched it all the way down. So this looks exactly like I took this corner piece and stretched it down a little bit. It seems like all of the dimensions stayed pretty much the same. We just got a little bit bigger. So I'm going to go ahead and circle A. B, I don't like. B looks like I took this horizontal side only and stretched it down, leaving this the same. So that's not my scaled copy. C, I also don't agree with. C looks like I stretched it, taking it this way. I don't like that, right? We're looking for that corner piece to come and take it and stretch it down. Part C looks like I took my vertical piece and just made it really, 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 really skinny. And then D looks like I took my corner piece and I moved it and made it a little bit smaller. It seems like my horizontal distance and my vertical distance both moved, so I'm going to go ahead and circle D. So which ones are scaled copies? We're going to circle A and D. Finally, we have question 4. Complete each equation with a number that makes it true. So every once in a while in these practice problems, you're going to see something that maybe references an earlier unit or an earlier lesson or something to get us ready for something in the future. So if we go ahead and look at this, it's asking me 5 times what gives me 15. So to think about this, think about your opposite operations. What can I multiply 5 by to get 15? That's just asking us to do 15 divided by 5. So hopefully you're doing this without a calculator if you're working on your multiplication. So 5 times 3 gives me 15. 4 times what gives me 32? That's just asking me to do 32 divided by 4. So that's going to be 8. And then 6 times what gives me 9? So think about what we did up here in the top ones, right? To find that missing piece, we're doing opposite operations. So in order to figure out 5 times what gave me 15, we really just did 15 divided by 5, and that gave me 3. Same thing here. I did 32 divided by 4, and that gave me 8. Now, part C is a little bit different because it's not as easy to think about 9 divided by 6. But if we go through and write it out, we have 9 divided by 6. I have a fraction, so I don't really need to know the decimal. I'm just going to go ahead and reduce that fraction. 9 divided by 6, if I reduce, think about what both 9 and 6 reduce by. I can divide them both by 3. 9 divided by 3 gives me 3. 6 divided by 3 gives me 2. So I have 3 over 2. So if you're good with your mixed numbers, ask yourself, how can I write that? So how many times does 2 go into 3? 2 goes into 3 one time with 1 left over. So it's 1.5. So you can write it in either of those forms, 3 over 2 or 1.5. So 6 times 1.5 gives me 9. I'm going to go ahead and do the same thing for D. 12 times what gives me 3? I can't think about that quickly in my head like I was able to do for this one, right? I don't know that fact as quick. So if we're ever looking for that missing piece, do your opposite operations. So 3 divided by 12, and I can tell it's going to give me a fraction because it's a nice number, not a nice number. So I'm going to go ahead and reduce. 3 and 12 can both reduce by 3. So if I divide both of these by 3, I have 1 over 4. So 12 times 1/4 gives me 3. Okay, just a little brain exercise for you there in question number 4 to get you to remember about your multiplication facts, inverse operations, how division and multiplication are related, some maybe review work with fractions. Okay, so there you have it. There's your answer key for lesson 1 practice problems. If you have any questions about these, please feel free to send me an email and make sure you're submitting this assignment. See you later, guys.